Okay, folks. I guess we should get going and see what we can accomplish. I'm hoping we're in good shape. I keep getting a message popping up on my screen that says my internet is unstable, so hopefully not so much. We'll find out here in just a little bit. A couple of things basically that I want to try to do this evening. One is to talk about the way in which you decide which statistical technique that you're going to use, or which one is appropriate for a particular scenario. And you know, sometimes that's not as evident as it may seem. I personally, I think it's fairly straightforward, and I use a fairly simple set of 3 or 4 questions to determine, you know, what I need to do or what kind of analysis I need to employ. And so I'm going to kind of walk you through those and talk about the things that we have already dealt with and where they fit into the mix. And then we'll kind of move on and look at logistic regression. And I want to do that in terms of an actual example that I'll pull up on a JASP page. And I haven't posted it up yet, but I will post up that JASP file after class. And then there will be another file that I'll post up along with an assignment in terms of dealing with these 2 particular concepts of chi-square and logistic regression. And then next week, in I guess the last session, last meeting that we'll actually meet per se, we'll talk all about different types of analysis of variance and a couple of other techniques that are used a lot in medical literature, though we won't have, you know, this course is really not designed to get into those in any great detail, but we'll at least kind of introduce you to those, and we can talk a little bit about, you know, some of the strengths and weaknesses, and I can kind of show you how those things provide, you know, some utility to you, or at least a utility of understanding when you might run across them in the literature. So that's kind of where we're going, and then there'll be a couple of online async assignments, maybe a video or 2, and then the final evaluation component. Now, the final evaluation actually will happen in stages. We'll have an early date, which will be somewhere around what would normally be the last week of classes, and you can complete it and turn it in. And then we'll have kind of a secondary date behind that in terms of providing some feedback on stuff you may have missed and giving you some guidance, at least in terms of what you might look at in terms of getting those things right, and then provide you with a second data set that will allow you to look at those things that you missed in a slightly different way, and then chance to remediate those in about a week or so, you know, kind of toward the end of the what would normally be the exam period. So you get 2 shots at it. I mean, you get the first shot, feedback, and then you get the second shot if you need it. So, all right. Any questions or comments or anything before kind of get into this stuff? All right, let me throw up my little overhead thingy here. Okay. As I kind of mentioned a moment ago, I have a sort of a process that I go through in terms of thinking about how I might analyze a particular set of data, or how I might deal with a particular question, and looking at the data and figuring out how to answer the question. And it really has to do with a couple of things. It has to do with the nature of the variable itself, and then it has to do with the nature of the question. Whether it's a question that speaks to are there differences between different groups? Is one thing better than another? Can we, if we tried a experimental sort of model, did the experiment work? Any of those sorts of questions, as opposed to, is there a prediction we can make? Is there some way to kind of predict a particular outcome? One variable depending upon other variables. And so the variable of interest, I always begin with that. And typically, if it's a sort of we're trying to infer any sort of causation, and so if it's anything like a causal sort of question, the variable of interest is really the effect variable. So if we're wanting to know if a particular reading program or a particular reading program has an impact on student comprehension, student comprehension is the variable of interest. I mean, that's the thing we're interested in kind of knowing about. If that's not the case, if we're more talking about can we predict a particular outcome with some degree of confidence, if we know some other stuff. In other words, if we know a person's entering score into a program, can we predict how well they'll do in the program? And so if it's a prediction sort of model, then we have kind of another type question, and we're not really looking for cause and effect. We're really looking to see, if we know certain things, can we predict other things with some degree of confidence? And so that's the first question I ask. What's the variable of interest? Now, for that variable, the second question I always ask is the nature of the variable. The nature of that variable of interest. It can only be one of two things. It either is continuous, which means it's a score or a interval scale, or some sort of average answer on a Likert scale survey or something like that. I mean, if it's something that I consider to be a scale score, whether it's an interval score or just a scale that has a numeric quantity attached to it, then I consider that to be continuous. And with continuous variables, there are certain things that we want to do, and so we'll mention those in a minute. Or it can be categorical. The variable of interest can be categorical, which means just that. It'll fit into one or more categories. And, instead of a scale, it'll be, success or failure, or passing or not passing, or moving forward in a program versus not moving forward in a program. Any number of things. But it basically is expressed in terms of pure categories and doesn't have any sort of scale score to it. And if that's the case, then for the variable of interest, then I go a different direction. So for the first one, if it's a continuous variable, I have to ask, a couple of questions, and I start with one, number of groups. And what are the number of groups that I'm dealing with? Am I dealing with, experimental control model, which would be two groups? Am I dealing with, differences across more than two groups? Am I dealing, what's the nature of groups I'm dealing with? And so, for all intents and purposes, You know, there'll be a few outcomes there. It could be one group. If it's one group, then you know I'm going to deal with that one sample t-test. But I have to know a little bit more because I have to know, you know, is there do I have a standard by which to measure it? Do I have a population variable to measure it against? Do I have something that I can compare this one group against? Typically, it's to some sort of what's called a population parameter, which is a measure of a population value. If it's two, that's going to be either an independent t or paired t, depending on whether it's pre-post or not pre-post. And if it's just two groups, then it's an independent t. If it's a pre-post setup, then it's paired t. Even though it's one group, the fact we have two measures, we treat it as if it were two groups when it's pre-post. And so we can have a scenario where you have two groups that are two actual groups, or you can have two groups just simply because you have a pre-post measure. And so you have a score for 3 and a score for post. Or you can have 3 or more. And if that's the case, then we're doing analysis of variance, because it doesn't matter how many groups you have for ANOVA. You can have 6 or 8 or 10 if you want, but for all intents and purposes, most ANOVAs are dealt with groups that are maybe 3 or 4 groups, maybe 5, because once you get beyond 3 or 4, it becomes a little bit problematic to really figure out what's going on. And so if you have 3 or more groups, then typically we do ANOVA. And then the other scenario is where there are no groupings. So we don't have continuous data for no groupings. We do have continuous data, but we don't have any groups. And so at that point, we are looking at more a predictive measure. So we're actually talking about a relationship between multiple variables, but we do have a variable of interest. Almost always we have something that we want to know, can we predict this, or can we figure out what we can know about this if we know something else? And since it's a predictive scenario, we're either going to do correlation or regression. But we're dealing with continuous variables. And so we're not, we're still dealing with continuous variables. We're just dealing with, multiple continuous variables, and we're looking for relationships or predictions, predictability. And so those are all with, these are all with continuous variables. Now, if we have the variable of interest is categorical, we have a categorical variable of interest. We have one of two things that we can deal with. Where'd my focus go? Focus on that. There you go. This autofocus thing, I'm still kind of getting used to it. A categorical variable of interest will make one of two decisions. It'll either be we're interested in a relationship. We have no causal effect. There's no cause and effect thing happening here. We're either interested in a relationship or we're interested in a prediction. And the prediction is what we'll talk about tonight in a little bit, but that's what we do with categorical variables. And so if we are categorical and related, that's chi-square. And if we are categorical and predictive, then that's logistic regression. Now, in either case, in both cases, neither one of these implies any sort of causal arrangement, no cause and effect. It's either just we're either looking at relationship or we're looking at prediction. And so, those are the questions, kind of the process that goes in my mind when I see a set of data and somebody tells me they want to answer this particular question or a particular question. In my mind, I kind of go through this process. What is, what's the variable of interest, or what's the thing that we're going to be trying to work with? Is it an effect variable? Is it a predictive variable? The nature of the variable of interest, continuous versus categorical, number of groups if it's continuous, number of groups if it's continuous. One, it's a one sample T. Two, it's independent T or paired T, depending on whether they're unique groups or whether it's pre-post. Three or more, it's ANOVA. If there's no groupings, then I know that it must be a predictive thing. And so if it's continuous and predictive, there's two particular ways of approaching that. One is correlational. If there's only two variables, I know I'm going to be doing correlation. If there's more than two variables, that I could possibly be doing regression, or I'll have to do regression. And then if we get into the categorical scenario, I'm dealing with either relationship or prediction. If I'm dealing with relationship, I'm looking at chi-square. If I'm dealing with predictive, I'm looking at logistic regression. Now, so tonight we'll kind of look at this. Well, we'll kind of review this, but we'll look at this too. And we'll kind of look at how those things are done, how those are calculated, what the data needs to look like, all that sort of stuff. And then next week, we'll go back to up here where we're talking about three or more groups. And so we'll look at some different ANOVAs that deal with three or more groups. And then we'll, as I said, add a couple of other little bells and whistles that we haven't dealt with yet. All right. Any questions at this point? Any? Let's say it's it's pretty straightforward stuff. It just happens to be you just go through a series of questions to figure out what you may be doing and what you can answer. Okay. Which brings me to an example of logistic regression. Now, as I mentioned last time, I believe, logistic regression is kind of a little bit of a different way of dealing with things as opposed to regression. Regression, dealing with continuous variables, I mean, it's very much about, thinking about predictions on the line. if we know what a relationship looks like, and we can kind of put a couple of variables against each other with a line, we can understand how related they are, understand the direction of the relationship, and understand the strength of it. With logistic regression, we're trying to predict something from categorical variables, and so we don't have the type of data that would allow us to create a line in a usual sense. But we can essentially apply the same logic without focusing too much on the line if we convert the data, the categorical data, into a base 2 log sort of data. And so you have categories that are 0 and 1. And so you have to have, at least the variable of interest has to be dichotomous. We have to have we have to be able to divide the responses on that outcome variable in a dichotomous way. If it's categorical, that's easy. We just have to collapse it into 2 categories. If it's a continuous in its natural form, might be a little bit more difficult. We have got to use either the median or the mean or something like that, to convert it into 2 categories. But we're essentially predicting, if we have predictor variables that have either predictive value or relational value on an outcome variable, a variable of interest that's dichotomous, we should see those predictor variables moving up levels. And if we've got them dichotomous also, it means they're moving up from 0 to 1 as the outcome variable or the variable of interest is moving from 0 to 1. And it's only a one-directional thing. We can't think what happens if it goes backwards. We can only think what happens if the predictors go from 0 to 1. Does the variable of interest, or the predicted value, also go from 0 to 1? And so it's kind of a unique scenario that was developed to do logistic regression. But it's a very powerful sort of technique, and it's one that we use as a gateway into a lot of other, kind of very sophisticated high-end analysis sorts of things. All these models I use to forecast the weather and, whether the spaceship actually hits the moon or blows right by or whatever. All those models use a lot of this sort of logistic regression modeling built into the model, simply because that one, it's a very, you can figure out effects on it. You can figure out, of different variables, which one has the greatest effect and what's the relationship between all those effects. And so it's a very powerful technique, but we're going to do a fairly simple example. I've got a JASP file that I'll share out. Now, I have not put this data file up, and so it's, the one that I will put up will be a little bit simpler than this one. And now, I mentioned about converting things from 0 to 1, or converting things into dichotomous variables and variables that are 0 and 1. That's what the statistical program does. And so you don't always have to do that to the data before you analyze it, because the stat's going to do that. It's going to look at it and going to say, okay, well, this has 2 levels, so whatever is the first level we'll call 0, and whatever the second level we'll call 1. And it sort of arbitrarily assigns the 0s and 1s, unless you have a particular coding that you've put into place, and then it will, you can kind of make it 0 and 1, or you can go through and create, new variables that are all 0 and 1. And so this is a a study that I looked at a few years ago, and I keep coming back to it because it's a pretty good example. And it looks at among entering community college students, are there things that predict which ones of those students will graduate? And in particular, for the study that we originally did this for, we were looking to see if the number of adjuncts they dealt with, the adjunct instruction level, had an impact on whether they graduated or not. And so, we kind of looked at that. And it has a lot of categorical variables in it. They're almost all categorical except for GPAs and things like that. And so I thought, okay, this will be a good one to play with. And so I drug this one up. We're in this particular scenario, and this logistic regression piece is underneath the regression tab, and it's just logistic regression. It gives you your list of variables. I've taken the liberty of already sliding the graduate variable in here, and that's whether people graduate or not from a program into community college. And I've put in two variables, and one of those variables is whether they were retained from the first year to the second year. Now, that may sound silly to say, okay, well, retention would mean they'd stay in school, which means they might graduate. Well, we did the graduation at the end of 4 years because we knew that there were students at the community college that very often will, they'll come a semester or two, and then they may disappear for a semester or two, and they may come back or whatever. And so, retention to 1 year is not the same as the number of students that end up eventually graduating. The level of graduation is typically a little bit higher than first year retention because there are people that for various reasons they may drop out for a semester or two and they may come back, or they may have to get some money together to come back, or things like that. So it's but it is a predictor, and so we put in as a factor whether they're retained at 1 year, and we also put in as a factor whether they were in developmental programs or not. In other words, did they take the remedial math or the remedial science program, or remedial math or remedial English program? Because a lot of students going into the community college do have to take those remedial programs. And so the only statistic that we added was something that's called odds ratios, and I'll point out in a minute why that's an important thing to add. And it's underneath the statistics button. But the example I put up will have all this screenshots, all that sort of stuff up to take a look at. And well, where did we go? We disappeared. There we go. Then, okay, well, the outcome is this prediction model, this logistic prediction model, is significant. It has a significant outcome. The coefficients, which are the things similar to logistic regression, similar to regression. Remember, regression was like the y is equal to mx plus b, where there was a value for the intercept, that was b. There was a value for m, which was a coefficient on the predictor variable. In this case, we have something similar. These are estimates. If we were actually going to do an equation, we would do an equation, we'd use these estimates. But we look to see what's significant. And the only significant predictor here Intercept, yeah, but we don't worry about the intercept at all. The only significant predictor here is whether they're retained at the end of the first year or not. And so that was a significant predictor. Whether they were in developmental ed or not was not significant. The p-value is not less than 0.05. Or the combination of those two. People that were retained the first year and in developmental ed was not a significant predictor. And so the only thing significant was the fact that they were retained from year 1 to year 2. So there was no break in their schooling. Now, this odds ratio thing here, odds ratios are really useful because they can be used to talk about likelihoods. What's the likelihood that something will happen? Now, this is different from probability. But what's the likelihood that something will happen? And in this case, we can say that people that were retained, yes, being the 1 value, not the 0 value, but the 1 value, the people that were retained were almost 4.8 times more likely to graduate than the people that weren't retained after the first year. So they're almost 5 times more likely to graduate. And so the power of logistic regression is that not only does it allow us to look at predictors and figure out, what might predict a particular outcome, in this case, graduate or not, but we also, once we find a significant predictor, we can then talk about what's the likelihood that as that predictor goes from 0 to 1, the outcome variable or the variable of interest goes from 0 to 1. And so people that were retained at the end of the first year or into the second year were almost 5 times more likely to graduate. And that's why retention is, such a big deal. Even if people might come back, you would prefer that they not leave. And so the whole value of logistic regression in a nutshell is right here in this odds ratio, because you can make predictions of likelihood, and it's not a probability, it's a prediction. They're 5 times more likely. And you can sort of flip that around. It's a little bit difficult to turn it around, but you can say if somebody's 5 times more likely to graduate, then if they were retained, then the odds of somebody that wasn't retained after the first year of them graduating is only about 1 chance out of 6. And so that's the power of this technique. It's a very strong predictive technique. And, it's one of the things that it does to allow us to, feel pretty strong about predictions. Now, as I said, the example that I'll put up for you is going to be a bit simpler. I'll use all zeros and ones. And I was playing with a couple of data files earlier today and didn't find one that I liked enough to use for an example. I'd hope to have that all completed by class time, but I hadn't found one yet that I really want to use as an example for that. But I'll crack open another backup disk, and I'm sure I'll find half a dozen of them. I just haven't had a chance to do that. But that's logistic regression. Now remember, logistic regression is a predictive technique using categorical variables. And so it's, if the variable of interest is categorical and you want to be able to predict the categorical outcome, first you have to convert it all to dichotomous variables, to one or the other. And if you do, then you have to be able to think about what might be the outcome. Now, I just had a student finish a dissertation. In fact, he defended it a couple of weeks ago, and we're just doing final edits on his dissertation right now. He'll be graduating in December, and he was doing the dissertation trying to use EVOS score predictors. In North Carolina, the way that teachers in elementary and middle school get bonuses or get extra money, merit money, and that can add up to as much as $5,000 a year on top of their salary. The way they get those bonuses is if they are able to advance their students, value-added measure, advance their students from when they got them to when they left, a certain value or a certain level of advancement. And so teachers are able to do that. They're eligible for bonus money. And this is in reading and math, only in reading and math. These EVOS measures, these value-added measures that they use in North Carolina to evaluate students and consequently to evaluate teachers, they don't take into account any of the demographics of the students, because there's some set of logic that they've gotten into that basically says all that's baked into the data set, and so we don't need to worry about that. Well, his question was, do any of these student characteristics have an impact on whether teachers get bonuses or not? And he had a data set of about 4,500 teachers, so he had a lot of data to kind of work with. And when he finished running that, it was kind of odd outcomes, because students that were ELL students and some minority students were more likely, at least in math, to be sitting in a class where the teacher got a bonus. And students that were disabled or students that were gifted were more likely to be sitting in classes where teachers didn't get a bonus. Now, you would think gifted students would, but when we began to tease all that out, what was actually happening for the gifted students is that their scores were so high to begin with, it was hard to grow them. If you're scoring at the 97th or 98th percentile to begin with, how do you get better? And students that were, ELL students or disabled students, their scores, initial, placement was fairly low, and so they had a lot of room to get better. And so the notion among teachers is that if you have bright kids, you'll get a bonus. Well, no, maybe not. That might not be the best way to get a bonus. You might want to have a few, not a whole lot, but a few ELL kids or a couple of disabled kids, and maybe you'll be fine. And so it was that was the kind of thing that we got into, was looking at this data, and what he used was logistic regression, because it allowed him to look at those different predictors and decide which ones had the greatest impact on whether teachers got bonuses or not. So yeah, that was kind of the crux of that sort of study and the crux of that analysis. And so it's as I said, it's a very powerful technique, but I'll come up with a very simple example that I can put up along with a very simple assignment to follow in terms of chi-square and logistic regression. Questions, thoughts about that? Okay, folks, that's all I was going to do tonight was logistic regression and talk about, what kind of variables and what kind of decisions you make about variables. This will go up. I'll put the example up. We'll meet next week. We'll talk about analysis of variance. We'll talk about a couple of these other techniques that are out there. We won't necessarily do them, but we'll kind of lay out some examples of them, and then kind of see where we are in terms of questions you might need answers to, and then kind of lay out the first scenario of the final evaluation, which I hope to put up by Thanksgiving. So it'll be up by Thanksgiving, and then you can kind of look at it. Okay, questions, thoughts? How about the little one? You got a question? No? Okay, good enough. All right, guys. Well, I'll see y'all next week. Have a good week. Have a great weekend. Stay warm. Got up this morning here. It was 12, so, it's a little colder than I like it, and I like cold weather. So, anyhow. So y'all have a good weekend, and I will see you next week. And let me cut this.